Constructive Voices, the podcast for the construction people, with news, views, and expert interviews.
Hi, I'm Steve Randall, and welcome to Constructive Voices, published in the week leading up to a major event for the future of the planet. The United Nations COP26 Climate Change Conference will bring together world leaders with the recent IPCC report fresh in their minds. The report warned that urgent action is required to avoid the worst impacts of rising global temperatures. And with the construction industry having a huge part to play in reducing carbon emissions and driving sustainability, we're joined by Darshil Shah, a specialist in natural materials who says change is essential.
All the signs have been so far that we haven't been doing enough. And I think the recent IPCC report should have been a wake-up call if people in the construction sector, but also elsewhere, were not already woken up to the urgency of the climate challenge and how we need to do climate action right now.
As usual, Peter Flynn, Pete the Builder, joins me to give his take on how changing the materials we use to build will affect the industry and the opportunity that a greener future offers. That's all to come.
What does connected construction look like? Viewpoint Construction Software connects your office, team, and field. Viewpoint's cloud-based project management and field solutions help contractors of all sizes manage projects, processes, and people, from the design phase through to on-site completion and handover. To learn how Viewpoint is helping Wilmot Dixon, Kia, Galliford Try, and over 8,000 other construction companies deliver projects on time and on budget, visit viewpoint.com.
The countdown is on to the UK's leading construction show. London Build returns to Olympia London's Grand Hall for the Live Expo on the 17th and 18th of November, and Constructive Voices is proud to be a media partner for the event. This year, the show will feature more than 500 speakers across 6 stages, hundreds of exhibitors, 200 plus CPD sessions, exclusive free-to-attend networking events including Meet the Buyer, Women in Construction and Diversity in Construction, and so much more. There are limited free tickets, and you can get yours at londonbuildexpo.com, and keep listening to Constructive Voices over the next few episodes for more about this major event. Now he's here as usual, Peter Flynn, Pete the Builder. How's things, Pete?
All good, Steve. Great to talk to you again.
Yeah, absolutely. Now, a lot of focus recently on this podcast and generally in the news about sustainability, about climate change. And of course, the reason for that is the COP26 UN Climate Change Conference, which happens in Glasgow at the end of October. So everything is kind of gearing up to that. And we've been talking a lot on this podcast about sustainability. And we've got a really interesting part of that solution on the show today, haven't we?
Yeah, it's such a good interview coming up today. So I very dramatically said that the first scene in a disaster movie had happened for us, and that was the IPCC report that came out. It was a global recognition that as a planet we are struggling and we are in trouble, and we need to address and start to try and gain back what the damage that we've done to our own planet. So they were very dark and direct statements. And like, let's be honest, like when I heard them myself, I was like, whoa. And as I said, and maybe it's just my brain, I felt as though I was in one of those movies where, you know, you hear about these things and then, you know, it starts showing the different effects, maybe the climate effect and that kind of stuff comes down the line. But like every good movie, there is always a solution. There is always the beacon of light and the moment of hope. And I think we're just about to hear that. Our guest today is a guy who works in material science, and he pretty much is, again, just as directly as we were told there were so many negative things happening, he is going to pretty much directly tell us about how many positive elements that we have already on our planet, and some of the products are already in use. I feel that this could be the breakthrough that we all need here, especially when it comes to construction and how we need to improve our carbon output, because he basically speaks about how his studies and the team that he's been working with, what they've been doing and what they have been doing is basically looking for alternative materials to use in construction, and not only in construction, alternative materials to use in lots of different industries. And it's about using materials that we already have on our planet. So really, really exciting stuff and really, really interesting. Like, this is such a good interview, and I really can't wait to listen to it again.
Well, we'll hear from Darshil, and it's worth mentioning, by the way, that we have a panel coming up after COP26. We're putting a panel of people together who will be discussing the implications of climate change and some of the things that are announced at COP26. And Darshil's going to be part of that panel, so we'll be announcing other guests to that panel soon. But it's very exciting, and that's going to be happening in November, so listen out for that. But we'll talk more about all these different materials and the impact and the implications for the construction industry after we've heard Darshil's interview in just a moment.
Constructive Voices media partner in Ireland and the United Kingdom is Construction Industry News. Since 2002, Construction Industry News has been focused on the very latest projects and developments within the UK and Ireland.
A reminder that we're convening a panel of experts to assess what COP26 will mean for the construction industry. Our guests include Victoria Burrows, the World Green Building Council's Director of Advancing Net Zero, and they'll help you get to grips with how things are set to change. So make sure you subscribe or follow the podcast using your favourite podcast app to get that episode automatically. And we'll talk more about the guests joining us on the panel shortly. Now, Constructive Voices brings you the thought leaders who are shaping the future of the construction industry. We talk about technology, well-being, design, and much more. And this time, we're focusing on materials. Let's hand over to Henry McDonald and our special guest.
My name is Darshil Shah. I'm a materials scientist and lecturer in materials at the Department for Architecture at the University of Cambridge. I also work and do science in the Centre for Natural Material Innovation, where we look at a range of different natural materials, particularly timber, bamboo, and their engineered composites, as well as linen, hemp, and their engineered composites as alternatives to materials like concrete, steel, glass, and carbon fiber composites for the built environment sector, but also a range of other application sectors.
So it's clear from your CV and many articles you have that you have a passion for developing and optimizing biomaterials. Where did that passion spring from, and what part of it has followed your overall career path?
So nature has always been a source of grandeur and inspiration for me. And after graduating as an engineer, I had the opportunity to undertake PhD research on sustainable materials and manufacturing methods for the wind energy sector. And that was the first time when, as an engineer, I was challenged to foresee problems of material sustainability in a sector that was already green, because we always associate with wind turbines with sustainable energy production methods. And that made me understand, think of, and design solutions that could actually make it greener. And to do that, I had to look at plants for solutions. I had to look at the seeds that you can extract from plants, such as linseed and hemp seed and soybean seeds, to make bio-based resins rather than resins from non-renewable fossil fuels. And also, how can we utilize fibers that we can extract from plants, such as, again, flax and hemp, as alternatives to high energy fibers, such as glass and carbon. And this was quite challenging because we weren't taught about plants and plant-based materials in our engineering curriculum when I was studying my bachelor's. And in most engineering and material science curricula, you're predominantly taught about metals and metallurgy, glasses and ceramics, concrete, synthetic composites, and if you're lucky, a little bit on wood. In fact, the term biomaterials is often confined to medical materials. So very little is taught about bio-based materials at all. And this is actually one key reason why I'm very interested in changing engineering and material science curricula to integrate a lot more nature-based materials into it and teach students and upskill them as to how you might use, develop, and design with these sorts of bio-based materials. But examining the structure and properties of plants and its derivative materials as sustainable alternatives, and importantly for the manufacturing sector, as drop-in replacements to the materials they are used to, such as glass fiber, was how I first got interested in optimizing biomaterials. And then since my PhD, my interest in biomaterials has widened and deepened because I have been lucky to study a variety of natural materials and structures as both a source of inspiration from very different disciplinary perspectives, and also in thinking and developing ways to utilize these bio-based materials for a variety of application sectors. So if I give you a couple of examples, following my PhD, I had the opportunity to carry out postdoctoral research at the Silk Group at the Department of Zoology at Oxford. And there I worked in a fantastic multidisciplinary group to develop silkworm and spider silk-based composites for toughness critical applications, for example, in the defense sector, in aerospace applications, and consumer goods like bicycle helmets. And also to study elephant ivory, such a marvelous material, but that which has endangered the life of the magnificent species. So the question, for example, in that case was, how might we recreate synthetic ivory that would help conserve elephants and prevent their poaching, but also ensure that skills and livelihoods of craftspeople that carve and work with ivory and have done so for hundreds of years are protected. So navigating through environmental, ethical, social challenges with these biomaterials, but also through an understanding of the science behind and around these biomaterials and the history of their uses and the importance to us and civilization. And then following my work at Oxford, I joined the Center for Natural Material Innovation at the Department for Architecture around 6 years ago. And I've again had the pleasure to work with scientists in a very multidisciplinary team of plant scientists, chemists, physicists, engineers, and architects, where we study natural materials and structures across length scales. So it ranges from studying their molecular architecture, so how do structural polymers in wood self-assemble and come together and give wood its functional properties, and then also how can we design and fabricate large-scale, sustainable, and beautiful buildings with these natural materials as alternatives to high-energy intensive concrete, steel, glass, and carbon composites.
And for an industry like construction, how do biomaterials reduce carbon emissions?
There are quite a few ways, but most importantly, plant-based building materials, particularly engineered timber and plant fiber-based insulation, or even other forms of materials, play a key role in reaching net zero ambitions by firstly enabling reductions in embodied energy, but also in operational emissions, while thirdly, storing carbon built in the structure. So there's a three-pronged approach to this. And the storing, the sequestering element is quite important. Plant materials store carbon, and they do so during their growth phase. In general, plant materials store around 1.4 to 1.8 kilograms of carbon dioxide per kilogram of material, and they do so by releasing the oxygen for our benefit. And of course, there are a variety of different plant-based materials, and some can be grown in higher densities, such as agricultural crops, from which we can obtain fibers, such as hemp and linen and straw. But also some can grow at a much faster rate, such as bamboo. And therefore, there are some plant materials that can sequester, capture carbon from the environment quite rapidly in a very short space of time. And using these materials in the built environment avoids emissions associated with the use of concrete and steel, for example. So there have been quite a few studies that demonstrate this. Switching to engineered timber construction at scale for new buildings, even in the UK, could result in dramatic embodied emissions reductions. And so far, one of the issues has been, and I'm sure we'll talk about this later, that embodied emissions are unregulated. And so far, they have been overlooked as well. And it's quite important that we try and get a grip on that. A 2020 study found that if 90% of the world's new urban buildings were constructed using engineered timber, about half of the embodied emissions associated with this construction could be avoided. And that's even before accounting for benefits associated with the long-term storage of carbon in these materials. And again, the use of plant-based insulating materials such as hempcrete, straw bales, wood fiber insulation could allow for achieving required thermal performance, so reducing operational emissions, while again having lower embodied emissions than conventional insulating materials, and still storing sequestered carbon long term. So as I mentioned earlier, plant-based materials avoid embodied emissions, They can help reduce operational emissions, and they also store carbon. So overall life emissions can also be lower, especially if we keep these materials in circulation.
One of the most intriguing projects you worked on was the world's first functional flax composite wind turbine blade. Two questions here, I think. One is, how does a turbine built from that kind of material stand up literally to the force of the elements? And secondly, how important was this as a development for the developing world?
Natural materials are much more resilient, stronger, tougher than we give them credit for. And actually, the properties of fibers such as flax and hemp comes from its building blocks. In their specific case, it comes from cellulose, which is the most abundant of biomaterials on our planet. So the stiffness and strength of cellulose are of the order of 130 gigapascals and over 1 gigapascals for strength. And this is with their density of around 1,500 kilogram per meter cube. So cellulose surpasses steel, glass fibers, and in some criteria, even carbon fibers. And it wasn't surprising to us that materials whose building blocks are cellulose, such as plant fibers, can produce engineered composites who would survive wind loads. So my specific research was looking at small wind turbines of 10 to 15 kilowatts that would power a typical 3 to 5 typical homes in the UK, and whose blades would be around 3 meters in length. And we did quite a full-scale analysis of these materials, and even at large-scale applications, so testing a flax composite wind turbine blade in comparison to a glass composite wind turbine blade as per ISO standard 61400, for example. And we find that in terms of fatigue performance, remember that wind turbine blades, particularly small wind turbine blades, are cycling at over 200 revolutions per minute, and they do so for a 20 or 30-year design life. So over that period, they would be cycling for over 10 million cycles. And even at those fatigue loads, flax composite do very easily well, in part because glass composite wind turbine blades are over-engineered, they're over-designed. They could last for significantly longer, but they don't do so for a number of other reasons. When we tested for their other mechanical properties, such as their strength and stiffness, again, we find that in normal operational loads, also in worst case loads, such as when there are gust wind speeds at 59.5 meters per second, you can design in a wind turbine so that the blades are yawed perpendicular to the wind direction, and therefore, even in those conditions, a flax composite wind turbine blade would satisfy certification requirements. I should point out that this work is not only relevant for the developing world, but also for the developed world. In fact, many sectors are looking to decarbonize quite quickly, and this is also true for the wind energy sector. Some wind energy companies in Europe, in the UK, have targets of being carbon neutral by 2030 without carbon offsets, and zero waste by 2040. And these are really ambitious targets, and they don't have much time. So wind turbines have a carbon payback period of between 6 months to an year, and almost half of the embodied emissions, so the upfront emissions on installation of a wind turbine, are due to the steel tower and concrete foundations, and about 15 to 20% are due to the embodied carbon in the blade. There has been quite recent development of converting steel towers to actually timber towers that can be 150 meters tall, for example, and that can significantly reduce the amount of concrete that is required for the foundations and make the towers carbon negative in the first place. Even though steel can be recycled, it's always much more practical and beneficial to have a carbon negative material in place. And with the blades, one of the problems is that glass and carbon fiber composites, which are conventionally used to make wind turbine blades, are currently landfilled at scale at their end of life after 20 or 30 years. And this happens in developed countries. So blades, you will see quite a few images if you Google or do an online search. Blades that are 50 meters in length are buried in landfill sites in Wyoming, elsewhere, and replacing glass and carbon fibers with plant fibers is one first step in the direction of thinking about circular materials or carbon negative materials. Of course, our work wasn't a stab in the dark. We were confident that flax composites would be suitable alternatives. And in part, this is because we are building on work that was done over 50 years ago. So while our study was the first study to demonstrate structural applications of plant fiber composites in wind energy applications, and the first study for any structural applications in over 50 or 60 years, there was precedent for the use of linen flax composites in load-bearing applications in the 1940s. So Spitfire fuselages in Duxford, close to us here in Cambridge, were being made from flax fiber phenolic composites as an alternative to aluminum due to supply shortages from France during the war. And George Washington Carver, a Black American agricultural scientist, had invented flax and hemp-based green composites using actually soybean-based resins for Henry Ford's Model T cars in the 1940s as well. So there is some historic precedence for our work, which we are continuing to build on. And I think the wind energy sector is trying to pick that up based on other work as well.
Going back to the construction sector, another biomaterial you work with is cross-laminated timber, or you call it CLT. Mm-hmm. How is it used in construction? And in a country like, say, the UK, could this become a core material in building buildings?
So it definitely can become a core material. And in Scotland, they are now trying to produce homegrown CLT as well, rather than it being imported. But even when it is imported from Scandinavia or from mainland Europe, engineered timbers have a big potential as being the core material for creating our future sustainable buildings. And we have to, because of the emergency and the urgency of climate action that is required. So cross-laminated timber, to those who don't know, is basically large-scale plywood in which laminae of planks of timber are laid orthogonal to each other in 0-90 degrees fashion and then glued together. And this produces a very dimensionally stable, reliable, and scalable building material with properties much better than the parent material due to homogenization effects. And in fact, one of the other advantages of CLT is that it can be used for rapid construction. CLT panels come in specific dimensions, but can be several meters in length and width, and are ideal for structural or partition walls, structural floors, roofs, amongst other building components. But it is only one of a few engineered timber solutions. So there's also glue laminated timber, in which the grain direction is the same, and you can use glue laminated timber rather than to produce floors and walls, to produce beams and columns, structural beams and columns. And you can also produce laminated veneer lumber, in which, like glue lam, you have one singular grain direction, but each layer of timber is actually much thinner. Rather than it being a plank, it's constructed from veneers 3 to 5 millimeter thick that are actually virtually free from defects, making it much, much stronger than even glue lam. So bending strengths can be 70 to 80 megapascals. And again, both combining its lightweight and high strength, these become very interesting materials as replacements to concrete and steel. And together, this palette of engineered materials, wood materials, offers rapid construction of buildings, reducing truck deliveries and construction traffic by up to 80% if you compare to concrete construction, for example. It reduces site time by several weeks, particularly because it is amenable or it is suitable for off-site prefabricated construction. So if you're looking at volumetric construction, you can actually prefabricate modules such as rooms or floors of buildings off-site and then assemble on-site, or you can precision cut beams and panels using CNC machining that can then be rapidly assembled on site as well. It offers a rapid construction technique that can produce reliable, safe homes, and the cost of CLT and timber construction is on par with other methods of construction, considering the whole construction phase.
And what about fireproofing it? Does it pose any further dangers, or can it be fireproofed?
No, so mass timber is inherently fire resistant through charring. And there has been a lot of research of the fire behavior of timber. And post-Grenfell, there continues to be even more research in this area. What is clear is that well-designed CLT or engineered timber buildings are fire safe. And for example, we know that CLT chars at a specific rate between 0.5 to 1.3 millimeters per minute based on the number of sides of fire exposure, for example. And therefore, it is common practice to oversize engineered timber walls or beams and columns. And this can provide 30, 60, 90, and even 120-minute fire resistance ratings, giving enough time for people to evacuate whilst the core material retains structural integrity and functions normally in the case of a fire. One can also encapsulate timber, such as with fireproof plasterboard or gypsum board. And encapsulation is another very effective way of fireproofing. There are also intumescent paints that can be applied to make timber fireproof, though these may need to be reapplied every decade or so. And they also have implications on the end of life of the material, making it difficult to recycle and bringing the circularity of the material into question, for example. But engaging with a fire engineer early in the process is one of the best ways to ensure that you produce a well-designed, fire-safe CLT building, for example, particularly a fire engineer who has experience with timber. In our center, we have previously looked at the fire behavior and high temperature behavior of materials like timber and bamboo. For example, we have looked at graphene-based polymer coatings of timber to make it fire resistant. We also use heat-based methods to innovate with timber as well. So for example, we are working with the Welding Institute to look at rapid fabrication joining methods with timber. So in a matter of 1 to 2 seconds, if you friction weld with timber without any glues, without any fasteners, you can produce a bond that is stronger than the wood itself and stronger than polymeric adhesives that we use today. And this is quite exciting research that we are continuing to look at that may have implications for the construction sector, but currently we are looking at furniture and other plant-based material sectors. And we are also looking at heat bending methods, for example, with bamboo and timber, so that it avoids the number of cuts that are necessary and is amenable to parametric design to produce beautiful shapes with these natural materials.
Your research, you're lecturing in all these interdisciplinary subjects, such as engineering, material sciences, and so on. But in regard to your students, can you think of any real-world construction projects that they're engaging with, that they're studying or maybe even working on?
So at the university, we have quite a few different types of courses, particularly the apprenticeship in architecture is one way we're actually teaching of how to use natural materials with digital architecture methods. So digital methods of fabrication and design, so parametric design, for example, that can be applied to real-world construction projects, including in projects the apprentices are currently working on in their practices. And we also run quite a few open-ended research projects that students engage in. So this year, for example, I have 2 students who will be looking at the design and fabrication of wind turbine towers made from engineered timber, actually American hardwood, for example. So diversifying the palette of plant-based materials, not just softwood CLT, but also hardwood CLT. We had a previous project in which we were applying what we had learned from the construction sector to other sectors, for example, in the sporting sector, to make cricket bats from construction materials as well, or waste construction materials. But a lot of other projects are also quite hands-on, looking at the use of hempcrete or straw bale or earth-based construction techniques to apply in real-world construction projects.
You just mentioned hemp there, another biomaterial. Now, can you outline how hemp can be deployed by the construction industry?
Yeah, sure. So hemp is a very exciting material and plant, actually. We've worked with hemp as humans for thousands of years. In fact, there is evidence that we started actively cultivating hemp about 12,000 years ago. That predates our cultivation of rice and wheat, which is really interesting. And over 12,000 years ago, we started cultivating hemp for two primary reasons. Firstly, for its drugs and medicinal purposes, and the materials that we can extract from it, fibers, from which we can make paper, but also construction materials, as well as its seeds and oils. Specifically for the construction sector, the materials that we can extract from hemp come from the stem. So hemp grows over a period of 12 to 16 weeks. It's a typical break crop, as we refer to it as. So it grows from sometime between March, April, May to September, October, November. And it grows quite rapidly to heights of 3 or 4 meters, thicknesses of 3 to 4 centimeters. And it stores carbon, it captures carbon from the environment really rapidly. It can be much more effective carbon storage material than timber in some ways, because of its rate of growth. From the stem, we can extract two main forms of material. Firstly, the fibers, from which we can produce a variety of preforms, such as felt-like materials, which you can use to produce green walls, so grow plants on. You can also produce textiles, from which we can produce laminated composite materials that are structural or aesthetic, depending on what your purpose of application is, impregnating these hemp preforms with resins that can be 100% bio-based, part bio-based, or synthetic to produce rain screens, roofing, cladding material, as well as joints. And then from the shives, which are a byproduct of the hemp crop, they are the woody, barky material. You can use that to produce materials like hempcrete. So the shives are mixed with lime and water and mixed together to produce basically an insulation material. It's non-structural, but combined with timber, it can give you a prefabricated solution that is structural. So those are the two primary ways one can utilize hemp, using the shives and the fibers. You can also produce plaster that uses lime and hemp to, again, as another sustainable material in comparison to other forms of materials.
As you know, all environmental roads lead to Glasgow and COP26. What are your hopes for the conference in terms of the promotion of biomaterials, especially with construction in mind?
I think all the signs have been so far that we haven't been doing enough. And I think the recent IPCC report should have been a wake-up call if people in the construction sector, but also elsewhere, were not already woken up to the urgency of the climate challenge and how we need to do climate action right now, particularly with plant-based materials or nature-based solutions. There is some positivity in that for the first time, COP26 will have a built environment day. I think that's November 11, where they will be discussing different solutions to how we can decarbonize the built environment. I think what I would like to see is firstly a discussion around embodied carbon and how it has been overlooked so far, and some important steps taken to regulate embodied carbon. Operational carbon has been, in our view, for a long time, but we really need to get a grip on embodied carbon and regulate it, alongside thinking of whole life carbon emissions. And this needs to be thought about both in developed countries as well as in LMIC countries, for example. We need to advocate the use of nature-based solutions and mandate these. And perhaps sharing of best practices would be a good way forward. For example, in France, in Paris, there are regulations which require for government buildings, so public sector buildings, to have at least 50% bio-based materials in their construction, either in the form of timber, straw, hempcrete, etc. So that's a good example. There are also examples that we may need to think about in terms of climate financing and thinking of supply chains and how we will promote the use of nature-based materials. So for example, Austria is considering paying €1 per kilogram of plant-based materials that is being used in a building, for example. And we really need to think about supply chains and climate finance from the very outset, because plant materials need time to grow. If you're thinking of hemp, 1 year timeline. If you're thinking of bamboo, at least a 5 to 7 year, because that's the harvest phase. And if you're thinking of wood, it can be 50 to 80 years ahead. So we need to be thinking about this right now to ensure that the nature-based solutions are not damaging biodiversity, so that we are using sustainable agriculture and forestry practices in their harvest and cultivation. I think there also needs to be quite important steps taken to reduce the amount of concrete and steel outright, and a recognition of their damaging effects, and also some form of a pledge or really constructive methods to reduce the emissions associated with concrete and steel in terms of making them much more greener as well. And then also a lot more discussion and actions to avoid demolition unless when buildings are unsafe, and again, retrofitting with natural materials wherever possible.
Leaving aside what governments do you think the hard-nosed CEOs of the building industry, do you think you have their ear? Do you think they're starting to listen to the necessity to get biomaterials into the business much, much more?
I'm not 100% confident of that. I think you always think of construction as either being concrete, masonry-based construction, timber-based construction. I think the material sectors are often put against each other, and that's not helpful. I think the CEOs of big building giants need to think of how they can incorporate more timber or plant-based materials as solutions with their materials. So even timber-based buildings will be using steel, will be using concrete. So they need to get more involved in how they would reduce the amount of concrete they use, reduce the emissions from the concrete, but incorporate more timber to make, for example, timber concrete composite solutions. And I think there needs to be much more action on that part. Also, a pledge to reduce the amount of emissions from those sorts of materials. There has been a lot of greenwashing, I think, in terms of carbon zero concretes and carbonation from concretes, and there was a lot of discussion around that as well. And I think they need to be very clear that concrete is not the solution, and business cannot go on as usual. There needs to be a step change in how we are constructing, particularly utilizing bio-based materials like timber.
Okay, so I'm a CEO, right, of a big construction firm. So I'll say to you, Dr. Shah, hold on a minute. What about my bottom line cost? Are you confident that your alternatives aren't going to drive my costs up?
I think the environment requires us to think beyond costs. That's one of my first points. Alongside costs, we need to learn to think how we can use less in general. So retrofitting is important, and reducing demolition is important. In terms of cost, there have been countless studies that have proven that materials like CLT and engineered timbers are on par with concrete and steel-based construction methods. The difference is how built environment is financed or construction is financed, because a lot of the savings with timber construction or timber-based construction come during the construction phase because of reduced site times, reduced truck deliveries, things like that. So perhaps there also needs to be some reformation or changes in how we account for the costs, but also account for the carbon budget as well.
Okay, one sort of very specific question maybe to sort of pay off is, on Constructive Voices, we have highlighted the issue before of plastic, one of the most pollutant of the materials that the building industry uses. What are your alternatives in the biomaterial sphere that can replace plastic from substances, everything from substance in paint to sheeting the whole bricks and so on? What is the alternative to plastic?
Yes, I think that's a really tough question, in part because my initial work has always started from plastics. I have worked with reinforced plastics, composites. And one of the challenges which you're talking about are actually to do with waste. And that is an ever important topic. And interestingly, it tells us that we need to also think beyond carbon emissions and energy requirements. Waste, for example, and water use are going to be other metrics for environmental sustainability, and we should not forget about some of these other metrics. And I also want to point out that plastics are an important category of materials. So, for example, if you do think about the pandemic we have been in, without face masks and face shields, which are often made from plastic-based materials, we would not have many solutions out there. So I think plastics do have a part to play. Some of the challenges associated with them are actually to do with how can we make the plastic sector more circular. And that's to do with, again, making sure that collection and disposal of plastics is better regulated or monitored. In terms of direct alternatives to plastic, we might have to think of more plant-based materials again as solutions that can undergo controlled degradation at their end of life. For example, that are either water-based or cellulose-based or chitin-based. There are a whole range of different biomaterials that can be alternatives to petroleum-sourced polymers.
If we really start focusing on biomaterials for everything, not just in construction, in other fields, are we in danger of stripping nature bare?
I think, that's a quite important question. And I think in no way when we study natural materials are we advocating for stripping out or reducing biodiversity or nature. In fact, we are asking for the contrary. We advocate sustainable forestry, agricultural practices, management practices to ensure that our forests are thriving and biodiversity is thriving, but we can also utilize plantations that are, again, managed sustainably to extract and harvest natural materials. Because as humans, we extract a lot of materials. In fact, a 2020 study in Nature demonstrated that anthropogenic materials, so human-created materials, particularly concrete, aggregates, steel, the mass of those materials have surpassed biogenic mass in the world. So the weight of all trees, animals, plants on this planet. And therefore, we need to think of plant-based materials. Also, a lot of the materials that we otherwise extract are going to be from mining or some other methods. Mining, for example, has quite important negative implications on nature anyways. So just like you would now consider sustainable mining practices and biorefinery, you do have to consider sustainable forestry management practices in which we can actively harvest natural materials for our buildings, for our vehicles, for consumer goods, whilst ensuring that forests are thriving.
So, Pete, as you sort of teed up earlier on in the podcast, the interview between Henry and Darshil Shah, absolutely fascinating I always like futuristic stuff. I always like talking about where we're going to be moving to next in terms of what we're going to be using. And in this case, the materials that the construction industry and the wider world will be using. Just exciting times ahead.
Yeah, what a super interview that was. It was so insightful. It's exactly what we needed to hear. It's pretty much using biomaterials to help get us back on track. A lot of the materials are in the test stage, but a lot of them have been used for years. Like he explained there that 12,000 years ago, humans were using some of the products that could be what we use now to help change, to help fight back, to help gain back our own planet. And look, this is not a sprint. This is a marathon. There's no doubt about that. And unfortunately, me and you, Steve, we may not be around to see the final days of this battle, but we all have to do our part now. And from listening to Darshil, what we need to do as an industry is we need to start accepting and adapting and using new materials which are very simply more friendly to our planet. It's really just about taking a step back, taking a deep breath and accepting change that is going to be coming. There's no doubt about it. I cannot see COP26 going by without some sort of major effect, if I'm honest, on our day-to-day lives happening, not only in our day-to-day lives at home, but absolutely in our industry and in how we do things at the moment.
Now, there are three things, Pete, that sort of have popped into my mind while we started talking about this and listening to Darshil as well. First of all, education. So, there's going to be some education needed within the construction industry on how to use these materials well and, the correct usage of them. I mean, everyone's so used to using things like steel and concrete and, and all the other bits and pieces that are day-to-day parts of the construction process. But, so there's going to be some education needed there. The other one is cost. And the third one is sustainability, making sure that when we take from the natural resources, we make sure that we're putting them back.
Yeah, 100% agree with what you said there. We do need to educate ourselves. The problem is we've got teams of people out there that are very used to using concrete. People have built their lives around using concrete and steel. I learned my trade with concrete, steel and, certain construction details. I'm kind of saying to myself, do I really need to re-educate myself now again and start having to go again? Well, the answer to that question is very simple. Yes, I do. We have gone through some massive revolutions in the last few years and we didn't even know it. And the biggest one being is the technological revolution we've gone through. I've mentioned this before, even since COVID. One major thing happened there was everybody got proficient on Zoom calls and on using different platforms of communicating with each other. And you know what? I wasn't great at that before. I was forced to do it. I had no choice. I had to do it. People said, you could never work from home because it just won't work and this, that, and the other. Do you know what? It does work and it is working and people are able to work from home. So things change, times change, and sometimes situations dictate how quickly something changes. It's like anything in life. Humans are very adaptable people and we all learn how to adapt. And we are going to have to do that when it comes to these materials. We're going to have to re-educate ourselves. We're going to have to learn how to use these materials correctly. We're going to have to learn how to use them efficiently and how to build our businesses around a new material. This is not going to happen overnight. We're not going to wake up on a Monday morning and then suddenly we're going to be using glulam beams and, for all our structural stuff and the different products that were discussed there earlier. We're not suddenly going to start using them. There's going to be an integration period. But you know what? It has happened already. I've used glulam beams loads of times on jobs and I actually love them. I'm a carpenter by trade. So if you tell me what would I rather use, timber or steel, I'd say timber all day, every day. There's different elements that are going to start coming into construction and there's different ways of doing things, but that happens in construction all the time. It's usually driven by an economic reason, or it's driven by maybe a change in how we do things. Like, obviously insulation in the last 50 to 60 years has become a huge priority, whereas before that, it basically wasn't even thought about. It was shelter is all we were looking for. And then slowly we start becoming a bit softer and we wanted warmth and we wanted different things like that. And we got a little bit more used to those kind of home comforts. So the building industry adapted with all of those things. Then technology started coming along. Again, we adapted. We set up our buildings to be ready for technology and to be easy to use, tech friendly, basically homes and buildings that were built. Now we're going to have to adapt. And again, the driving factor in this one is going to be simply because our planet needs it. No other way of putting it. It's as simple as that. Now, again, this is not a negative. People resist change and people don't like change. But once you get over the first period of it and once you accept it and get on with it, a lot of the countries in the world now have smoking bans. If you had said that 40 years ago that there would have been nobody smoking in a restaurant or nobody smoking in a pub, you would have laughed at them. The reality is that's where we are now. So again, adaptation will happen and change will happen and people will accept it and people will move on it. So we do need to educate ourselves. There's no doubt about that. But that education will come. And I don't think it's going to be that hard for us, being honest with you, because a lot of the materials we will have already probably have used them. And again, in construction, we are always used to using different materials, doing different construction details as we need to and as situations change and as jobs evolve and as projects evolve, we evolve with them. And this is just another case of that. When it comes to the cost, look, there's no doubt about it. The cost will have a huge part to play in this. But what is the final cost of this whole thing if we don't do this? We're going to deteriorate our planet. So you cannot have a short-term sight on this. You need to look at this and say, the word sustainable, sums it up. is it sustainable to continue on living as we are and doing things as we are? No, it is not sustainable. The cost will definitely have a bedding in period, and we're going to have to see, I'm sure some products will come out and, they may not do exactly what we're first thought about. It takes a while for all products to settle in. But like Darshil goes through a lot of different products there. He talks about the fact that they're fire retardant and they can reach certain regulations and they can get certain properties into them through different uses and through different ways of doing things. So a lot of the boxes are ticked there, Steve, on this. But as like anything, you can't suddenly change something overnight. It's going to take a little bit of a bedding in period. It's going to take a little bit of adjustment. And you know what? We have to do it.
Absolutely. And of course, we're recording this before COP26, so we don't know yet what will be decided there in terms of perhaps subsidies for certain materials.
Well, I can answer that question for you right now, Steve. There will be subsidies there. There's just no doubt about it. Countries are already doing it. And they have to do it because each country has a target to meet, and there's very few countries that are actually even close to their target. So there are subsidies available, and there are grants and incentives available in most countries to help assist, especially when it comes to construction, to help assist with domestic homes, to try and get the domestic homes up to a more carbon neutral or close to a carbon neutral if they can. Design has changed. People are designers and engineers, architects, any building professional have that in their remit right from the start now. So these elements have already started to be introduced, and there's no doubt about it, there will be subsidies. But I suppose it's really about how long it takes for that to play out, and how long it takes it to really start hitting home. And the other thing about this, Steve, and we might as well talk about it and be open about it, this is going to create massive opportunity. I've said this before, and I'm really, really sure of this. The world is changing, and like any change creates opportunity. People made a lot of money during world wars. People made a lot of money during the pandemic. People made a lot of money during lots of different situations. When you've got a global situation, it creates opportunity, because when there's a problem, there needs to be a solution. And if you're the person that can come up with the solution, or you can provide the solution, or you can provide the materials, or be part of the education that's the solution, all of the existing industry will have to adapt. But there's going to be opportunity created here, and if people are clever enough, and if people are ahead of the curve, and if people are willing to put the work and the effort in, they can get out there and they can create opportunity. Because again, there's nothing wrong with making money, lads. I love hearing when a man or a woman has been so successful because they had enterprise and they went and took the bull by the horns and took an element of construction or an element of any industry and made it their own and progressed it on and made good money out of it. They fully deserve it because they've put the effort in, they've done it. So if you're listening to this podcast right now, opportunity is on its way. Pete, the builder, has let the secret out. There's opportunity out there. Look, try and get involved in it. Adapt your own business. See how you can get ahead of the curve. And you know what, you don't have to be a scientist, or you don't have to be the person who's at the groundbreaking part of this. You can be the person further down the chain, because that's how economics works, and that's how industry works. There's always a product, and then there's always how do you get that product distributed, and how do you get the knowledge about those products distributed. So there's a lot of stuff happening. Again, really, really exciting stuff, but so positive. And I'm so happy that we've heard this interview, and I'm so happy that we now have the light at the end of the tunnel. And even better, again, that it's not completely unusual to us, or it's not completely out of our realm that we've already been working in, because we know these materials. We've used a lot of these materials, but we've used them in different ways, and they haven't really had they're not in the mainstream just yet, but they're coming really, really soon.
Yeah, that's good to hear. And obviously, when we do a next episode, COP26 will have already started. And as with, so many things, and we were talking about the subsidies, with so many things, the devil is in the detail. Let's hope that there's firm commitments there and long-term commitments so that things can really escalate. And I mentioned earlier that Darshil Shah is one of the guests on a panel that we're putting together to discuss COP26. And this is going to be a fantastic event that we're putting on here. Our main guest for the panel is Victoria Kate Burrow. She's the Director of Advancing Net Zero at the World Green Building Council. It's going to be a fascinating conversation and panel discussion on this, Pete?
Yeah, we always try and stay ahead of things, and we always try and spread the good word. But the team that we've put together for this panel it's so strong, and people that are right at the heart of it. And we're going to get this panel together within a matter of weeks of COP26. So we're going to get the inside word. You're going to hear it here on Constructive Voices, and I'm so happy to be part of something that's coming and is so close to the source. We're going to try and get as much information as we can for our listeners and for the construction industry in general. And we've got the right people coming on board here. So it's a really, really strong panel. Again, like always, we won't be afraid to ask the questions.
No, absolutely. Let me tease another one of our guests, and more will be confirmed, by the way. But Claire Wansbury, who's an ecologist and associate director at Atkins, that's a world-leading engineering and environmental consultancy. So we've got Claire, we've got Victoria, we've got Darshil, we've got more to come. It's going to be a very, very interesting event happening in November.
To have such a strong panel together that are going to be able to discuss all of this and be able to give us direct information on it, it's a fantastic opportunity for anybody to really obtain that information literally from the horse's mouth, as they say,
Absolutely. Well, look, Pete, I'm going to let you go and stock up on the popcorn and stuff, ready to be glued to COP26 coverage over the coming weeks, and we'll talk again next time.
It's hemp and it's biomaterials that I'm stocking up on, and maybe popcorn might be one of them as well. We could be using popcorn for insulation. You never know.
It could be the modern day Pebble Dash.
Sounds good to me.
Cheers, Pete. And that's all for this episode of Constructive Voices. Thanks to Darshil Shah for his inspiring insights into natural materials. Remember to find and follow us on social media and your favourite podcast app. You can even ask Alexa to play the Constructive Voices podcast. And please share this podcast with others that you think may be interested. Our website is constructive-voices.com. Don't forget the dash, where you'll find details of everything we talk about and what's coming up, including that special COP26 analysis episode in November. Until next time, thanks for listening. You're really helping us build something.